Hello students, this is Notes 4-6 and it's solving quadratics using tables. Okay, so the question is, tell which interval a solution to the equation f of x equals 0 is found, or tell if it is a double or an imaginary. If it is a double, give its solution. So let's talk about that for a second. When you find a solution, when you have a quadratic and it's graphed, a solution is where it's going to be on the x-axis. So what you need to understand is that the y values, when it gets to that point, the y values are positive, like if we follow it from the left to the right. They're positive, and then they go negative. They're still negative, and then they come back to positive. So basically what we're saying is that a solution is going to fall in between where y values are changing signs. Okay, so that's how we're going to do part A. Part B says, tell what interval the vertex is found. Okay, so the vertex is going to be found in between the two solutions, okay? And I'll show you how to do that when we work some of these problems. The other question is the vertex a maximum or a minimum? So we're going to do that on all five of these tables, okay? In the first table, first we're going to figure out where our solutions are. So look at the y values, which are right here. The y values where they're changing signs, okay? Well, they're changing signs between 4 and negative 1.3, and then again at negative 2 to 1.8. So the interval of x is going to be on the left side, so it's going to be in between those two points right there. So tell which interval a solution to this equation f of x is found. You're going to look at the x values and you're going to write it as an interval. So remember that's it's a between statement. So it's when x is between negative 6 and negative 4.5. Okay. The other interval is when x is between the negative 3 and negative 1.5. Okay. The vertex has got to be between those two intervals. So the vertex is going to be somewhere in here. Now what I want you to look at, though, is the negative 1.3, it goes lower to negative 2, and then it starts coming back up, and now it's all the way up at 1.8. The thing is that my vertex could be in between any of those three numbers there. So we're going to say that the vertex is going to lie where x is between negative 4.5 and negative 1.5. I'm going to leave these open because I know it can't be exactly those numbers. And then C, is the vertex a maximum or a minimum? So I want you to look at these y values. So the way the y values are written here is that it goes positive, then negative, and then back up to positive. So if that's the case, then it's going to look something like this. Therefore, the vertex is a minimum. All right, let's look at number 2. So first, look at where the y's are changing signs, and that's going to be where your solutions lie. So it's going to be between negative 1.5 and negative 0.5. And then it also changes signs here. So let's write that. It's going to be between negative, and I guess I probably shouldn't put a less than or equal to. It should just be less than. It's got to be less than x is between negative 1.5 and negative 0.5. And then it's also, x is also going to be between 1.5 and 2.5. So I'm going to go over here and I'm going to change these signs here to just less than. The reason why is because I mean, the solution is where y is equal to 0. Well, in neither one of those spots is y equal to 0, so it can't be equal to those values. Let's see, -6. Okay. All right, so going back to number 2, part B is the vertex. Well, the vertex is going to lie in between the two solutions, and if you look at these negative values here, it goes -2.5, then it goes lower, -7.5, then it starts coming back up. But the thing is that I can't tell where the vertex, it could be between these two numbers or it could be between these two numbers. I don't know. So I'm going to include all three numbers. So it's going to be where x is between -0.5 and 1.5. And then look at the y values. It's positive, then it goes negative, and then it goes positive again. So that would be a minimum. The vertex would be a minimum. So the whole point of this assignment is to interpret these tables. So I want you to try and do number 3 on your own, and then press play when you're ready to check your answer. Okay, so for number 3, I got that the solutions are going to fall between -5 and -4 and 1 and 2. Now on the vertex, I want to talk to you a little bit about that. The vertex, basically what you're going to do to find the vertex is you want to find the y value that it is either the highest or the lowest, depending on how it's opening. Well, here we've got negatives, and then we go positives, and then we go back to negatives. So this quadratic is going to look something like this, so that we're looking for that highest point. And the highest point is at 17. So to find the vertex, you're always going to go on either side of that, unless on either side of it, it starts repeating again, and that means then that is the vertex. So you're going to pick the 3 values, or the 2 on either side of it, that surround that vertex, or that highest point. All right, let's move on to number 4. Okay, so number 4, we want to look for the y values changing signs, but you'll notice that they're not going to change signs at all. And so that means that we have a solution, and it's right here. Because you see that they're positive, and then it goes to 0, and then it starts going positive again. So basically what that's going to look like is it's going to come down, hit the x-intercept, or the x-axis, and then start going back up again. So it just has that one solution, which is at 5, 0. Okay? And again, we call that a double solution, so you can write that down. And then the vertex, well, if that is my solution, then that's also going to be my vertex. And then because it opens up, then that vertex is a min. Okay, number 5. Okay, so on number 5, it's positive, and then it stays positive all the way through. So basically what that means is that you've got a quadratic that's only above that x-axis. So it's not going to have any real solutions. These are going to be imaginary solutions. So you're just going to write that down. And then the vertex, well, the vertex, you can see that it's positive, and then it goes down to 3, and then it starts repeating again. So my vertex has got to be in between those two values. So it's when x is between 0 and 1, and it is a minimum. All right, this is short and sweet. We'll work on it some more in class tomorrow. Have a good evening.